Hi friends, welcome to our channel. Let's look at problem 3804, number of centered subarrays. This is a daily challenge problem. In this video, we are going to use a set data structure to address this problem. So let's quickly look at this problem requirement. So here we are given an integer list called nums. So a subarray of nums is called centered if the sum of its element is equal to at least one element within the same subarray. So we want to return the count of such subarrays, right? So based on this definition, first, each single element subarray is a centered one, right? And also you can look at example 1, right? So the output is 5. So we have 3 single item subarray. And if you look at 1, 0, you will get sum is 1. So this is the 1. And if you look at the whole array, so the sum is 0 and 0 is inside. So overall you will get 5. And if you look at example 2, so you're going to get 2. Because if you consider 2 elements subarray, the sum is -1. And -1 is not inside the whole array. So the important thing for this problem is that the constraint. So here the length is bounded above by 500. Therefore, this problem is a small size problem. And therefore, we can solve it in a roughly brute force fashion. But because we are going to consider sum, so we need to use a certain prefix sum or partial sum. And also we need to check if the subarray is centered. So we're going to use set data structure. With that said, we are ready to look at the code. First, for convenience, so I'm going to get 2 pieces of information. One is the length, so this is just for iteration, and also I'm going to initialize a set. Right? Notice the way we are initializing a set. So you cannot do something like this. Sim equals this will be a dictionary. So though initialize dictionary, you can have the sen, or you can use sen equals dict. But for set, you're going to use this one. So once you have this, then you can do a prefix sum. So answer equals 0. Then actually we can consider for each subarray, so it has a start and then it had an end, right? So we can for each start index I, we want to find the potential ends. Let's call it J, right? So basically for I in range M, right? Then, so the sum, we can call it, let's say the sum is 0. And then we're going to iterate. So for the ends, so the ends can be anything like this. You can ending at I, right? Single element. And then also you can end before M, right? So then in this case, the sum is incremented by the current number, that is G. So then the sum represents the current sum starting from I and ending at G. So we are going to check if this sum is inside this sim, right? So basically, let's first add this nums J to the element. So here I first do add because single element is valid centered subarray, right? So then we are going to check. So we are doing int. So if sum is in sim, if so, we are going to increment the answer by 1, meaning that we find a valid subarray starting at I and ending at G. So this is for all subarrays beginning at N and possibly at G, right? So then later we just clear, right? So we need to start over from another starting point. And this way we can return the count, right? So this is one way to do that. Let me do a quick run. Yeah, it passes the 2 test cases. So now let's submit. Yeah, it passes all the test cases. So here I would say, due to the fact that this problem is a small size problem, and also due to the definition of centered subarray. So it actually hints us to use set data structure. This is one part. Another part is to use partial sum or prefix sum. So with that said, I guess that's it for the current video. Hopefully this will inspire you to think of more solution formats. Thank you for